All right, what do we do first?
Change the secant to 1 over cosine x.
Okay, go to sines and cosines. So if you don't have this correct on your paper, please fix it as we go through. So you have these 1 over cosine x divided by cosine x minus tangent is
Sine x over cosine x.
And cotangent is
Cosine x over sine x.
all right. Now, first big strategy, we will use this one all the time. How do you divide fractions?
Multiply by the reciprocal.
Yes. So the top stays the same, times, and flip the second one.
Oh, sorry.
Good. So now, when you take 1 over cosine x times cosine x over 1, what happens?
It's 1.
It's 1. So we get 1. Hold on, something's not right. Did you...
I for sure took some similar liberties with my math on this one. I'll be honest.
Okay, here's the mistake. Right here.
Oh, wait.
This is cosine x over 1, so when you flip and multiply, it would be 1 over cosine x. So then when you multiply, those cosines don't drop, they're both on the bottom. So you have 1 over cosine squared x minus sine times sine would be sine squared x over cosine squared x. All right. Now what did you do?
Oh, wait. Never mind. Can I put something on the board?
Sure. All right, you have a common denominator, so you can write those in one fraction. And then we are almost there because you have 1 minus sine squared x, which is cosine squared x. Kind of look there over on the board. I wrote that main formula and we talked about the different variations if you subtract things over. So we can change this to cosine squared x over cosine squared x. And what's anything divided by itself? 1.
Oh my gosh. I didn't know these problems could turn into like just movies.
Nice and pretty.
That was crazy. I thought I always had like, and with the thingy.
Who would like to come up next? All right, we'll just keep working. Ryan, you want to come up? Thank you. Willing volunteer right here. So check first. Now, are there any main formulas that jump out, like any of the Pythagorean identities? If not, we usually go to sines and cosines. So what could you change cosecant squared to?
That'd be 1 over sine.
1 over sine squared x. All right, and what's tangent squared?
Sine over cosine.
So since they're both squared, it'd just be sine squared x over cosine squared x. And then we still have that minus 1 on the end. Okay. So these are multiplied. What happens there?
The signs cancel.
Since if anything's on top and bottom and you're multiplying, it drops out. So we get 1 over cosine squared x minus 1. All right, 1 over cosine, reciprocal of cosine.
Reciprocal cosine is 1 over secant.
So we would just write it as secant squared x. Minus 1. All right, look at your identities, guys. Pythagorean identities. Is there anything involving a secant squared? Which one? Tangent squared plus 1 equals secant squared. So if you subtract over that 1, secant squared minus 1 is equal to tangent squared. Yep. So from that Pythagorean identity, tangent squared x. And that's our final
I
answer.
have one question. So, I thought it always had to be like cosecant and sine.
Cosine and sine, is that?
Yes.
That's usually where we start so that we can try to manipulate things. But your final answer doesn't
It
have
could
to
end
be.
up as in.
Yeah. Yeah.
Where did we find the secant squared x?
We had tangent squared theta plus 1 equals secant squared theta. And so if you subtract the 1 from each side, secant squared minus 1 is just tangent squared.
Thank you.
You're welcome. All right. Number 5. Anyone really want this problem? All right. Thank you.
Can I do 6 then?
Sure.
I'll do 7.
Okay.
So,
Okay.
start by boiling this one.
Right. That means we have 2 of them, so FOIL it.
All right. Foil the next one. Wait, I missed one.
You just missed a minus
one.
sine x cosine x. So you can put it on the end. Okay, so what we really have right now, when you FOILed, you have this plus this. So that's kind of on one big line together. We just don't have room for all that up on our slide. So now when you start adding like terms, what do you get?
2.
So sine squared x plus sine squared x is 2. Sine squared x plus 2 cosine squared x. Okay. Do we know what that would be equal to? What if I wrote it like this? Since they both have a 2, we can factor with trig functions.
Oh yeah.
So if I pulled out that greatest common factor, what is sine squared x plus cosine squared x? 1. So you have 2 times 1, which is 2. So final answer is 2. All right. Good. Number 6. So there are a couple ways of doing this, and one is much faster than the other. What'd you do? Did you do an identity first?
I did secant squared over.
Yeah,
sec
That's
squared.
your
Yeah, you know.
cosecant. Yeah.
Yeah.
So if you recognize these are both Pythagorean identities, and if you start there, that's going to save you a lot of time. So 1 plus cotangent squared is
What was weird?
we have cosecant squared.
Am I writing super big?
It's okay.
Okay. I can't tell.
Not a big deal. Those should technically be x's just because they were x's in the original problem. But all right. So now, what would we change these into? So cosecant squared would be 1 over sine squared. Let's go to x. Divided by. How do we divide fractions? Right. So if you multiply, so she brought this up to the top, multiplied, and then cosine squared divided by sine squared. Cotangent squared x. Good. Yes, ma'am. I think somebody else already volunteered. Did you? I don't care who does it. I think we had volunteers for 7 and 8 already. All right, what would we do here? FOIL. Go ahead. So now what happens?
Those cancel out.
Mm-hmm. Cosecant squared x minus 1.
Equals cotangent squared.
Yep, from the Pythagorean identities, we had 1 plus cotangent squared equals cosecant squared. So cosecant squared x minus 1 is cotangent squared x. All right. Number 8. Right. This is a lot like problem number 2, where you only have one term on the bottom, so you can break it apart. All right, and then 1 over tangent x. Mm-hmm. And tangent x divided by tangent x is?
1.
Mm-hmm. So we get cotangent x plus 1. Good. Are we all right with that one? Tangent divided by tangent. Anything divided by itself just turns into 1. Yeah. Who would like the next one.
I can do the next one.
Thank you.
This turns into tangent squared x. Turn that into
Okay, so it's multiplying. And then what happens?
and then you can do like the
Actually, you don't need to do that though, because they're not adding; they're just multiplying.
okay.
So if the same thing is on top and bottom, you can just cancel them out.
Okay.
So-
So still sine squared.
Did anyone do this problem differently? How'd you do it?
Actually, the one I was gonna do was 1 over cosine x squared
Mm-hmm.
minus 1, and then that was 1 minus cosine x squared divided by cosine x squared.
And-
Just from there, that was it.
Yep, that works as well. So there's not just one way of doing it. You could have gotten it multiple ways here. All right. Is this one okay? Number 10, I will do the first part with the negative angles if somebody will take it from there after I get that part done. So negative angles, we have those negative angle properties. Keep in mind what this means. This is saying you need to do cosine of negative x and then square that answer. What is cosine of negative x? Regular cosine x, and then when you square it, you just get cosine squared x. All right, this means cotangent of negative x squared. What's cotangent of negative x? Negative cotangent x. But when you square a negative, it becomes, so that's plus cotangent squared x. All right, this means sine of negative x squared. If you do sine of negative x, what's that equal to? Negative sine x. But then when you square it, it becomes positive. Anybody want to do it from here? You can add in any order, right? What's cosine squared plus sine squared? So we have 1 plus cotangent squared x. And what's 1 plus cotangent squared? You could go to sines and cosines, or you could use that Pythagorean identity. That is just cosecant squared. We've seen dividing by fractions, flip and multiply. That's came up several times. I'm changing things to sines and cosines. We use a lot. The Pythagorean identities are really, really useful. I want to focus more on some of the algebra things that we can do. If I gave you, let's say, 1 over 1 plus cosine x minus 1 over 1 minus cosine x. we've talked about if you want to add or subtract fractions, what do they have to have? Common denominator. All the ones we've done so far, luckily already had that common denominator and we were able to put them together. But in algebra, we know sometimes things didn't, and we could get a common denominator. So if I look, this first one has a denominator of 1 plus cosine x. What does it need? So I'm going to multiply by 1 minus cosine x on top and bottom. What does this one need? So 1 times 1 minus cosine x is just 1 minus cosine x. On the bottom, we could FOIL. So we get 1 minus cosine x and plus cosine x drop out, minus cosine squared x. Second fraction, 1 times 1 plus cosine x is 1 plus cosine x. Bottom, we get 1 plus cosine x and minus cosine x cancel, minus cosine squared x. Now these denominators are the same, so now we can put them together, right? If there is a subtraction here, what should I do with that? So everything in the second parenthesis will get a negative. So if I combine my terms, 1 plus negative 1, 0. Negative cosine x plus negative cosine x. Negative 2 cosine x. We are really close to being done here. What is 1 minus cosine squared x equal to? Sine squared x. All right. One more strategy that we are learning today that we have not used before. This is all one term, right? There's no adding or subtracting. We have a negative 2 cosine x on top. The bottom is sine squared, so that's like saying sine x times sine x. We agree with that? So we have a negative 2. What's cosine divided by sine? Okay, then I'm just left with a sign on the bottom, or you could think of it as 1 over sine, which is cosine. So the only reason I'm allowed to do that is because it was all one term, no addition or subtraction. So we can break things up like that. Let's try another one where I reorder those terms like that at the end and make sure we can do that. Are there questions on the getting the common denominator part? So if I gave you this is just a beta, it's another Greek letter, no different than having an x or a theta or whatever else you might have for a variable. This is all one term. So I can reorder things if that is helpful to me. Would you guys agree this is the same thing as if I said sine over cosine times tangent. Okay. What is sine divided by cosine? So I have tangent beta times tangent beta. So that's just tangent squared beta. Let's do one more strategy. If I gave you can I cancel these? No. When things are multiplied and it's all one term, we can reduce, but this is more than one term. Think about if I had given you like x squared minus 9 over x minus 3. What would you do to reduce this? What would you do with x squared minus 9? You'd factor it, right? We can still factor with these trig functions. Sine to the fourth minus cosine to the fourth. That's a difference of squares. So if we set up two parentheses, we know in a difference of squares, one of those is plus and one's minus. If you have sine to the fourth, half of them go in each parenthesis. So it's sine squared x, cosine to the fourth. So each one gets a cosine squared x. I could factor the bottom, but I'm not going to yet. Is this helpful right now? Yeah, because it's all one term, so we could cancel. So we have sine squared x plus cosine squared x, which is okay. So what we're doing now, in section 2, we are doing proofs. The difference between what we have been doing and a proof is we know the final answer in a proof. So I am actually going to give you a full equation to start with. My suggestion, we are not treating this like an algebra equation that you're trying to solve. So you're not moving things from one side to the other. We are going to box in one of these sides and we're not going to touch it. So we're basically looking for which side looks easier. The left or the right? The right looks a little bit nicer, I would say. So I'm going to box that in. I am not going to touch this. This is what my answer should be. So now I'm going to work this problem just like all the other problems we've been doing for this week. But I know when I get to the end, I should have 1 plus tangent t. So you know what your answer is. That's why the work is so important. Okay? So if I had to start here, what would you do? Distribute. Do you want to distribute it as a secant, or do you want me to change that before we distribute? We could do it either way, but sure. Well, I heard both options. If you want to change it, I'm going to change it in a second, either way. But if you kept it,
So we're working on the harder side?
Yes. Yes. What could you change secant to? change both of those secants to a 1 over cosine. This is like a sine t over 1, cosine t over 1. So when you're multiplying, you just multiply the tops and the bottoms. So we get what? Sine t over cosine t plus cosine t over cosine t. What is sine over cosine? And what is cosine divided by cosine? Is that the same as 1 plus tangent t? Yep. So what I want you to do is box it in. So when I look at your problems, I should see 2 boxes that match every time. Now, that also means you can't really do the work in your head because you know the answer is 1 plus tangent t. So I don't want to see somebody that just says, yep, that's 1 plus tangent t. You can't just say you did it all in your head and expect me to believe you, okay? You have to show me the steps. Not that anybody in here would do that, but it's happened before. All right, so really these are kind of a little bit easier because you'll know when you have the right answer. Try another one. So which side would you box in? Right. So I know my answer should be cosecant squared theta. Now I have to get there. There's more than one correct way to get there, so it just kind of depends on how your mind works. What do you think about doing? What are your all's ideas? Distribute? Okay. Yeah, you could change tangent squared plus 1 into secant squared. So you can either do that identity, you can distribute first, or you can change everything to sines and cosines first. There's really 3 different options. Which one do you guys want me to do? Okay. If you want to do a different way, you're welcome to go ahead and try it on your own and see if we get to the same point. Okay. Cotangent squared times tangent squared. What could I do with that? What's cotangent squared? Okay. What's tangent? I'm going to leave this cotangent here for a minute. What happens when I multiply these? It cancels. We have the same thing on top and bottom. If everything drops out, you are left with 1. What is 1 plus cotangent squared? Pythagorean identity. That is cosecant squared theta. Did you guys get it from the other way? So here's what I'm going to do. I know we haven't done very many of these. I'm going to go ahead and give you some problems, but they aren't due tomorrow. All right, so I'm giving you 8 problems now. You know enough to work all of these, but I will be adding to it, and it won't be due until probably the end of class on Friday. So tomorrow there'll be 8 more, and all of them will be due by the end of the day.